Okay, we have discussed about the intersections of two lines, a line with a plane and the intersection of two planes. And in this lesson, we are going to discuss about the intersection of three planes. So a system of linear equations is a set of one or more linear equations. So when we solve a system of linear equation, we are trying to find the values of the variables that will satisfy all the equations. So we submit all the unknowns, they should satisfy all equations. So three planes, we are going to have three equations. So number of solutions to a linear system, we could have only one, or none of them is zero, or infinite number of solutions. So equivalent system will be the two systems. We have the same solution. We call them equivalent system. And the consistent system means it has one solution or infinite number of solutions. Inconsistent, it has no solutions or zero solutions. So we have a graph that show you that the first four cases will be the okay. So these four cases are consistent system. So it has three planes, then it has one point of intersection. It means we have one solutions. And this one, three planes, they intersect at one line. If it's one line, it means we have infinite point of intersections, and also it means infinite solutions. So this one is two of them, they are constant, they are same, and intersect with another one is a point, is a line, so infinite point of intersection again. All three of them, they are same, so infinite point of intersections. So all of them, we call it consistent system. Now we are going to see four of the inconsistent system. So three of them, they intersect with three parallel lines. And none of them will be the common, so it's zero solution. No common points from these three intersects. This one intersect at two parallel lines. So these two parallel, then there's no common. No common means no point of intersection. There's no solution. So three parallel, no intersection, zero solution. This one parallel, two of them same, so zero solution. So there are several different cases for the intersection of three planes. So now we are going to see one example, and when we solve, so we are going to see one example. So we have three Cartesian equations for planes. So equation 1, equation 2, equation 3. And you will see this method also you could apply it to any equation system. So this is three variables, three equations. But here we give it a meaning is a three planes intersection. So we are going to get the number at front of the xyz here. So 2, -3, 1, and the right side is 6. So we put a bar here, and 1, 1, 2, 31. 1, -2, -1, -17. So we have row 1, row 2, row 3. And the first thing we want to check if they are parallel. Parallel means with times the number, they are going to be exactly same. If they parallel, we need to check this side, the number same or not. If not same, no solutions. If same, it means you have two planes, they are same. So our goal is like what we did for the two planes, we want 1, 0, 0. The second one, only y is 1. The last one is only z is 1. So here on the other side will be a number. Then from this one, we are going to get x equals that number. This one, y equals that number. This is z equals that number. So that's the reason we want to change this matrix to 1, 1, 1. All other elements, we call them 0. So we could times a number to each row. It won't change the final solution. And we could add or subtract the rows. So, and we are going to see how we are going to be able to get 1. We don't want to divide this one by 1. We could just switch. So we could just switch the R1, R2. Then we are going to have 1 for the first element, the first row, first column. So we just switch it. 1, -2, -1, -17. And here we want to write R1 switch with R2. This is our operation, okay? And after that, we want to focus on the first column. So the step 1, we want A11 to 1. How to get it? We could switch or add, subtract. So if we also could subtract R1 minus R2, we will have this one as 1. Okay, so first step, we want the first column, first row, the number is 1. Then step 2, what we want to do is the first column becomes 1, 0, 0. And how we do it is just subtract and times a number to 1. Then we are able to get the same number, then we subtract. So this one, 2 minus 2 times 1 will give us 0. So we copy the first row. We don't want to change it. We want to keep the first column, first row, 1. Then this is our first one. Then second one, we are going to R2 minus 2 times R1. So 2 times 1 gives us 2. Then 2 minus this times 2 gives us 0. So 2 minus 1 times 2 is 0. -3 minus 2 times 1 is -5. 1 minus 2, or I could just write more steps, okay? You don't have to if you know how you are able to do the calculation right away. So 2 minus row 1 times 2. Then -3 minus row 1 times 2. Then 1 minus row 1 times 2. 6 minus row 1 times 2. This is R2 minus 2R1. Then the third row is just subtract R3 minus R1. So 1 minus 1, -2 minus 1, -1 minus 2, 31, -17, minus 31. So this is how we do the subtraction. Then what we are going to have, I will simplify it. We are going to have 1, 1, 2, 31. Then this one is 0. This one subtract is -5. This one subtract is -3. 6 minus 31 times 2 give us -56. 1 minus 1 is 0. -2 minus 1 is -3. -1 minus 2 is -3. This is -18. So this is what we got from this one. And this part, you don't have to write it. You could just jump from here, then just write This is R2 minus 2R1, R3 minus R1 right away, okay? So you could jump from here right here instead of show the middle step. So we show the middle step, then we want to see the step 3 is we have 1 0 0 already. We are going to focus on the second row column. Second column, we want to have 1 as one at that element. So this one, -5, -3, -56 divided by -5. We are going to have fractions, so we may see the last row. So if the last row all divided by -3, we are able to get 1. So this is what we want. So we are going to have divided everything by 1. And also after we divide it by 1, we want to switch it with second row because we want the second column, second row to be the 1. So we copy the first row here. Then we divide it -3 and switch it. So 0, 1, 1, 16. Then copy the R2 here. Okay. So this one R2 switch with R3 divided by -3. This is how we got it. Okay. Then after that, we are going to change these two to be 0. So this one, second one got 1. Then after that, we are going to multiply and subtract to change these two to be 0. So equals the first one, this is 0, so minus, it doesn't change this number, it's still 1. So this one, if we keep the R2 here and R1 subtract R2. So 1 minus 1 give you 0. So we keep the R2 here, we don't touch it, but we change the second column, other numbers 0. So R1 minus R2, 1 minus 1 is 0, 2 minus 1 is 1, 31 minus 16 is 15. Then the R3 minus R2 times -5. So -5 minus -5 give us 0. This one 0 minus 0 is 0. So this one -3 minus 1 times -5 give us +2. Then -56 minus 16 times -5. So we could write -56 minus 16 times -5. Then I will just write it a little bit bigger. So this one minus 16 times -5. Then it will give us 24. So step 4. Step 4, we have 1 0 0 0 1 0. We want the last one to be 1. So this one to be, we don't touch these two because it's a 1 0 0 1 already. We only want to touch the last one. So we want to change this one to 1, then just divide by 2. So we are going to have the last column, we are going to keep it here. It will be 0 0 1 12. So the last one works. Then we are going to see the second one. So we have the 1 12 as the last one. We want to get rid of these two. We just subtract R2 minus this R3. So this is 0, won't change these two. Then this is 1. 1 minus 1 is 0. 16 minus 12 give us 4. And the first one, 1 minus 0, 0 minus 0 doesn't change. 1 minus 1 is 0. 15 minus 12 is 3. Then this is R1 minus R3. So we change it to 1, 1, 1 as diagonal. All the others are zeros. So our final answer will be x equals 3, y equals 4, and z equals 12. So this is corresponding the number at front of x, y, z. So 1x plus 0y plus 0z equals 3. 1y equals 4. 1z equals 12. And this represent we have a point. So the point of intersection is 3, 4, 12. So this is how we do it. And so first step, we want the first column, first row to be 1. If not 1, we could add subtract to make it 1. After that is 1, then we change others to be 0 by multiply a number to the first row, then subtract from this. And after that, we focus on the second row, second column, make that one to be 1. So don't change the first row. So first row, we leave it there, but change the other two to make it 1. You could add, subtract these two columns to get the second one to be 1. Once the second one is 1, then we times the second row and the minus from that second row to get the other two elements on the second column to be 0. Then after we have 1, 0, 0, 0, 1, 0, we focus on the third column. Third row, third column to make this one to be 1. Then we subtract and times the third row to get rid of the other two to be 0. Then after we have it, we got this solved. So now we are going to practice more. This is a point of intersection, only have one intersection as a point. And next one, so sometimes we may have a line, so we are going to see practice more. So solve the system using Gauss-Jordan elimination. That means the matrix again. So we are going to see, remember, align them properly. So the number at front of the x, y, z, we get them out. If one variable not there, it will be the 0. Okay, 1, 2, 3. So we find the numbers. So 1, 1, 2. The number at front of x, y, z. So this is x, this is y, this is z, and this is a constant on the other side of the equation. So the second one is 3, y is -1, z is 14, and the constant on other side is 6. The last one is 1, x, 2y, no z means 0 times z, then -5. So row 1, row 2, row 3. Then after that, the first one is 1 already. We like it. We don't have to. So step 1, A11 need to be 1. It is 1 already. That is good. We don't have to change. If not, we could just switch R3 with R1. Then you have the A11 equals 1. Then step 2. Step 2, first column. So we have 1 here. The other numbers, we want to change it to 0. How to change them to 0 is just add or subtract the number times R1. Okay, R1 stays same. So row 1 stays same. 1, 1, 2, -2. Then R2, 3 minus 1 times 3 will give you 0. So 3 minus 1 times 3 is 0. -1 minus 3 times 1. So we could write it out. So 3 minus 3 times R1 give us 0. The second one, -1 minus 3 times R1 is 1, give us -4. 14 minus 3 times 2 give us 8. Then 6 minus 3 times -2 give us 12. So you just make it a little bit bigger. You don't have to write the middle steps here, but I want to show you what we have done. So 3 times -2 give us 6 plus 6 is 12. Then the last one, R3, is 1 already, 1 minus 1. So just R3 minus R1. It will give us 1 minus 1 give us 0, 2 minus 1 give us 1, 0 minus 2 give us -2. You don't have to write this 0 minus 2. You just give me the final answer. It's okay. So -5 minus R1 -2 give us -3. Okay. And you don't have to write all the middle step. You could just write 1, 1, 2, -2. Then we have 0, -4, 8, 12, 0, 1, -2, -3. So this is after the subtraction what we are going to have. And the step 3, we know what we want is a second column. The second row is 1. So it's not 1, we switch it. So we are going to switch. Keep the first row here for now. Then we are going to switch R3 with R2. Then we have 0, 1, -2, -3, 0, -4, 8, 12. Okay. So R2, R3 switched. Then we continue. We want to make the second column other numbers to be 0. So it equals the second row stay here. So 0, 1, -2, -3. Then change the first row, second column to be 0. It's just R1 minus R2. Then it will work. R1 minus R2 is 1 minus is 0. 2 minus -2 is 4. -2 minus -3 is +1. Then the R3, in order to change the second column to be 0, is R3 -4 minus is plus 4 times R2. So 1 times 4 plus 8 will give you 0. So 0 times any number plus 0 is 0. So 4 times 1 plus -4 is 0. -2 times 4 plus 8 is 0. 12 plus 4 times -3 is 0. So the last one, no contribution. It also means the z could be anything. We could introduce a parameter here. So it seems that we may have infinite solutions. So this is actually we couldn't simplify further because we don't have this one as 1, so it will be just this way. We couldn't get rid of these two numbers. 0 times anything won't give the 4 to be 0. Okay, so now we are going to write 1x plus 0y plus 4z equals 1. And the second one is 1y minus 2z equals -3. And we write z equals t, and solve for x, y, we are going to have the component vector is kind of like the parametric equation. So x equals 1 minus 4 times t, and y equals negative 3 plus 2 times t, z equals t. So this is t belongs all real numbers. We know this one is a line, equation of the line in parametric form. Also, we could write it as vector equation. So vector equation, we just find all the constants. That is our point on the line. So negative, positive 1, negative 3, 0, then plus t times the direction vector, the number at front of t. So negative 4, 2, and 1. So t belongs real numbers. So the intersection is a line. So it has a infinite point of intersections for these 3 planes. So now you will see if we have 1 here, we have 1 point of intersection. If this one is 0, then we have a line, and the z will be t any numbers. So this is what we have covered, and we get the number at front of the xy side here, then put a constant on the other side here. Then step 1, we make sure a11 equals 1. The first one is 1. Then we want to change the first column other 2 numbers to be 0 by subtract or add numbers. So 3 minus 3 times 8 give you 0. And sometimes it's not always subtract. We also have plus. This is negative 4, then 1 times 4 plus it give us 0. So we change all the first column 1, 0, 0. After that, we want to change the second column, this one, to be 1. Don't touch the first one, because the first column is not 0. So we focus on these two R2, R3 to find 1 here. If not 1, we couldn't find it. We could add, subtract, or divide to get the second column, second row to be 1. Once we have this one 1, then we want to change the other 2 to be 0. So if we have the numbers here, then we want to change these 2 to be 0. By adding, subtracting, and multiply the second row to make the other 2 0. Then we try the third row. So this one we don't have the third column, because the third column, this one is 0. So we couldn't change it to 1. If it's a number here, we divided that number to both sides. We will get this one to be 1. Then we could add, subtract, and multiply a number to this one to get this 2 to be 0. Then we have 1, 1, 1 diagonally. Then we have x equals, y equals, and z equals. So thanks for watching, and this time please do the understanding, check your understanding on delta math. So this time we have the delta math questions. Thanks for watching. And this is also our last lesson. Congratulations, you made it.